Hey everyone, so we're going to continue our discussion where we talk about how to solve exponentials, this time where we won't have common bases. So we talked about how to do exponentials with common bases, now we're going to look at it without. Before we continue, we'll work on some of these questions. So in the do now questions, here we have logs on both sides, so what we can do is set the insides equal to each other. Then what I can do is move things around so that I get everything to one side. So I'm just going to move this entire thing over to here. X squared plus 11x plus 28. Here I have a quadratic, so I need to find two numbers that multiply to 28 and add to 11. So in here, this will be x plus 7. X plus 4. Since 7 plus 4 equals 11 and 7 times 4 equals 28. This tells me that my two solutions are going to be x equals negative 4 and x equals negative 7. I can plug this in and see that this is exactly what I get. So we'll do it really quick. Negative 4 squared is 16. 16 plus 30, the left-hand side becomes log 36. The right-hand side of the equation, negative 11 times negative 4. Negative 11 times negative 4 is 44. Oh, sorry, I did this wrong. This is 46 because 16 plus 30 is 46. So 44 plus 2 is 46. So we get the same answer here. Down here, negative 7 squared plus 30. So negative 7 squared is 49 plus 30 gives you 79. The right-hand side, negative 11 times negative 7 plus 2. 11 times 7 is 77. Plus 2 is 79. Again, we get the same thing on both sides. All right, so down here, same thing over here. There's a few different ways we can go about doing this. I'll just do this. So I'm going to move the ln x over to the other side. Now, before I continue, I need to get rid of this negative in front of the ln. I'm going to actually turn it into an exponent on the x, like that. From here, I can set the insides equal to each other. So this is 8 equals x to the negative 1. I can move the exponent onto the other side. And I get which is x equals 1 over 8, or some decimal. I think it's 0.125. I can check this by going into the calculator and just seeing if essentially if ln 8 plus ln of 0.125 gets me 0. And when I do that, I do get 0. So there we go. Now we're going to scroll down. So normally if we have a scenario like this where we have an equation set up, what we can do is rewrite the, one of the numbers to have a common base. So here we can write the 32 as 2 to the 5th. So this could be rewritten as 2 to the x equals 2 to the 5th. Now that I have the bases the same, we could say that the exponents are the same, therefore x equals 5. Now the issue is if we have a scenario like this, 2 to the x equals 30, we can't rewrite 30 as a power of 2. So we would not be able to do the same method. What we'd have to do instead is essentially get rid of the exponential factor. We're going to do this by, there's a few different ways of doing this. The way I'm going to do it is by taking the log of both sides. So here, because this exponent is up top, I can move it down over here. Divide both sides by log 2. So I get x equals log 30 over log 2, which when I plug it in the calculator, I get that x equals 4.91. So that's the method that we're going to be doing here. All right. So going through these practice questions, well, since we have, we're looking for the n exponent, we're going to do the same thing where I'm going to take the log of this. Log 6 to the n equals log 99. That n gets moved in the front due to the power rule for logs. Now, since I want to get the n by itself, I can divide both sides by log 6. We're doing it to the nearest thousandth, so this becomes log 99 divided by log 6. And we get n equals 2.56. Oh, wait, sorry, 6.5. Over here, what we're going to want to do is first isolate the term. So since we have the 2 on the left-hand side, we want to move it over to the right. So we end up getting e to the b equals 30. I'm not going to take the log of both sides. Instead, I'm going to take the ln of both sides since I'm using the e term. Once again, the b goes in front. If you recall, ln of e actually just drops out because that's just equal to 1. So b equals ln of 30, which when we plug it into the calculator, gets me that b equals 3.401. All right, what we're going to do here is, again, try to isolate the exponent. So we get the 5 over 18 to the 6x equals 5. Take the log of both sides. Move the exponent to the front. Now what I can do, because I want to get the x by itself, I want to divide by 6 log 18. So x is going to be equal to log 5 divided by 6 log 18. Just make sure that when you put this in the calculator, you put parentheses around this so that it reads it properly. You should get 0.9, 0.093. All right, this one. So again, want to get the exponential term by itself. So 81 minus 3 is 78. Take the log of both sides. So I think this is going to be the last time I write out with the exponent. Mostly just because it's the same method each time. So I'm pretty much going to skip this, this step right here. So divide both sides by log 9. So I get n plus 10 equals, and then I could do log 78 divided by log 9, 1.983. Subtract 10 to both sides, and we get negative 8.017. All right, so for number 5, we're going to divide both sides by 6. So we get 2x plus 3 equals 5. Take the log of both sides. This exponent drops to the front. divide both sides by log 2. I get x plus 3 equals log 5 divided by log 2, which is 2.322. Subtract the 3, and you get negative 0.678. Over here, to get rid of that, to isolate the 9, we're going to cross multiply. So I can put this over 1, get a fraction, multiply both sides by 3. 9 to the n equals 441. Take the log of both sides. Divide both sides by log 9. We have 2.771. Okay, we'll do a few more of these examples. So first thing I want to do is add the 2 to the other side. So I get 4e to the 2x equals 5. Divide both sides by 4. We get e to the 2x equals 5 over 4. Take the ln of both sides because I'm using e this time. Remember, ln of e is actually just 1. So this becomes 2x equals ln of 5 over 4. Divide both sides by 2. So in the calculator, I write ln of 5 divided by 4, close the parentheses, divide by 2, and I get 0.112. Over here, because we have log terms of the same base, we could actually just set their insides equal to each other. Subtract 3x, subtract 17. 5 minus 17 is negative 12 equals 3x. Divide both sides by 3. So we get x equals negative 4. Okay. We'll do 2 more, and then I'll see if there's any special questions, because for the most part, it's continuing the same process. So here, 5 to the c equals 7. So take the log of both sides. Divide both sides by log 5. So log 7 divided by log 5. To the nearest thousand, it would be 1.209. Over here, take the log, since that term's already isolated, I could just take the log of both sides. I both sides by a log of 1/2. So log 3 divided by log 1.5. Negative 1.585. All right. So that's the main gist. Let's see if there's any, we'll just do this last question. So last one, we're going to want to isolate that e term so we can subtract the 8 from both sides. So we end up getting 4. Divide both sides by 2. You get e to the x equals 2. From here, I can take the ln of both sides. This just drops to 1, so this becomes x equals ln of 2. And when we plug this into the calculator, we get x equals 0.693. All right, and that's it. If you have any questions, please feel free to let me know. You can message me either on mine or through Canvas or through email. Otherwise, good luck and have a great day.